Color coding is a really important principle when we're trying to prevent cross-contamination of lubricants. The reason why it's so important is because you may have 30 different lubricants on site, maybe even more, and it's very easy to just pick the wrong one off the shelf. Particularly because, let's say, for example, in a particular brand, Castrol, for example, all the drums are exactly the same color. It's very difficult unless you actually go and you read the label. It's hard to know exactly what you're picking up or what you're transferring into a dispensing container. Not only that, sometimes that label may have rubbed off. Maybe it was in the sun and the ink has kind of worn down. Sometimes it can be difficult to read. So having your own internal system for color coding and labeling lubricants is a really, really important thing. So let's talk about how we go about color coding our different types of lubricants, because there are a couple of off-the-shelf systems out there, but I think that it's probably better to build your own one from the ground up. So as an example, right, and just to be clear, this is not a criticism in any way. This system could be perfectly good for your application. You really need to evaluate them on a case-by-case basis. So here, I've got, this is publicly available information that I grabbed off the internet. This is from Lubrication Engineers. So LE, but not affiliated with me. So Lubrication Engineers actually has a standardized tagging system that they use for different lubricants. And basically what happens is the different colors correspond to different types of lubricants. So hydraulic, circulating, R&O, gear oils, etc. And then as you go down the list, you use different shapes to identify the viscosity grade. Now this could be a perfectly good system, right, for your particular application. It may fall down somewhere, right? So let's say, for example, the green is synthetic oil. Well, yes, that could be a synthetic oil, but synthetic oils come in a whole range of different varieties, don't they? We don't just have PAO synthetics. We have alkylated naphthalene synthetics. We have ester-based synthetics as well, right? Esters are a really common compressor lubricant. So do we want to have them all in that same category? No, not necessarily, because an ester is a very, very different lubricant to a PAO. Now, one thing that you'll notice is over on the right, they classify PAGs, polyalkylene glycols, as its own group. And that makes a lot of sense because they are incompatible with all the mineral and PAO synthetics. So we need to kind of tease out what is appropriate for our particular site. Now, this one is, I think, a really good reference guide, and it gives you a good idea for how would we color code basic lubricants in a standardized industrial environment, right? I think this is a really good example. But one thing that you'll notice, there's no engine oils on here, right? It's very, very common in, let's say, power generation applications to have maybe some stationary diesel engines on site for temporary power generation. So that doesn't really fit in with this system. Let's say, for example, if you are in a food manufacturing facility and everything that you use is food grade, well, now it doesn't make sense that we're going to color code everything in light gray, right? We would want to use a separate system. So I think using one of these off-the-shelf systems can be very effective, right? However, we need to evaluate it on a case-by-case basis. Now, let's think about how we could color code. Because the thing about color coding is there are only so many colors that are available to us, right? We have a spectrum. And there are fundamentally 6 different colors. Now, you could argue, when we learnt the rainbow when we were in kindergarten, there are 7 colors: red, orange, yellow, green, blue, indigo, violet. But I would argue that it's very difficult to tell violet from purple, for example. There's actually some really interesting science around color theory and the fact that if you ascribe a name to something, then visually, color is kind of cultural, for example. So, let's say, for example, in the vast majority of the Western world, pink and red are 2 completely different colors. Well, when you think about it, pink is actually just light red. But for some reason, in our minds, we see them as 2 very distinct colors. I have heard it said, I'm not Russian, so I can't speak to this, but my understanding is in Russia, light blue and dark blue are similarly considered to be completely different colors rather than 2 shades of the same color. So we need to also apply some cultural context around this, right? So color theory needs to play a role in how we ascribe different colors to different lubricants. All right, with that out of the way, let's now talk about how you can organize the lubricants on site by different colors. So we've talked about this system before where we talk about as we go down this list from base oils to R&O oils to anti-wear, EP, and detergent-based oils, they're getting more additized. So an example of a base oil would be like a heat transfer oil. Something in the R&O space would be like a turbine or a compressor or a circulating oil. Anti-wear might be hydraulic. EPs are typically the gear oils, and then engine oils are the ones with the detergent dispersant packages. Okay, so as we're going down the list, we're getting more and more additized. So that gives us sort of like a generalized framework for how we can understand lubricants. And their use cases are typically different, right? Base oils, very large closed systems. R&O oils, smaller systems. Then you've got boundary and mixed lubrication, shock, loading, and then applications where you see a lot of contaminants. So we treat these lubricants very differently and we use them very differently. So now, as we go up and down the list, we could ascribe, for example, these different colors. And it would make sense to do it in this order because, let's say, for example, if I go from a base oil to an R&O oil, realistically, all I'm doing is I'm adding rust and oxidation inhibitors. Right? So the chemistry of a base oil and an R&O oil is relatively similar. If I were to go from an R&O oil to an EP oil, those have quite different chemistries and different use cases. So that's an instance where I wouldn't want to mix them. So in a similar way, I want their colors to be as far away from each other so that we don't make a mistake. All right. So it is feasible, for example, that if someone went and picked something up off the shelf, that they could mistake red for orange because those two colors are quite close together. Well, that would probably be okay because when you pour it into an application, an R&O oil and a base oil are relatively similar. Same thing goes for like an EP and an anti-wear. If someone mistakes yellow for green, right, we want to make sure that those two lubricants are similar enough that we're not going to have a catastrophic failure. But if, for example, I poured a detergent-style engine oil into a turbine, right, that could result in a huge problem, right? We know, for example, that with steam turbines, demulsibility characteristics are really important, its capacity to separate water. Engine oils don't do that. They hold on to water. So we want to make sure that we're, the lubricants that are very far away from each other in chemistry, we want to use colors that are very far away from each other as well. Okay, that's kind of the principle that we're using. Now, not only is the chemistry different, but also we can have that the base oils are different too, right? We can use mineral, PAO, ester, and PAG. And typically, right, if you looked across the list, this is the kind of combinations that you would typically see. So, PAGs, sometimes you'll see them in turbine and compressor applications. Occasionally, you might see them in gear oils, like for worm gears. So a mineral worm gear oil, for example, would typically be something which is compounded with these fatty acids. So this kind of gives you, let's say, the diagram of very, very common oil types. On top of that, you've got some specialty lubricants, right? Food grade, paper industry, some maybe environmentally degradable, right? So these need specialist colors because they're used in specialist applications. So if we have an application that can only take biodegradable lubricants, we want to make sure that that is a very distinct color from everything else that we have on site to ensure that we're not contaminating with the wrong oil. That's a really big deal because maybe we end up with regulatory issues, right? That becomes a compliance issue. Now, stack on top of this, you've probably also got a whole bunch of greases on site. We want a separate color coding system for those, maybe with a sort of a pattern on it, so that we know that this is a grease versus a lubricant. And there you might want to distinguish it by thickener type, for example, because we know how much the thickener type plays a role in compatibility of those different greases. So now let's try and construct what we could do, how we could practically develop our own color coding system on our own site. So I'm going to strip away a few things here. So first of all, I'm going to pretend that this is a generalized industrial site, and I'm going to take away those greases. I'm going to take away the specialty lubricants as well, and I'm going to assume that we don't have any heat transfer systems. Now, In a typical industrial environment, right, we also often don't have engines on site, right? In a power generation application, you probably have engines, but let's say in a manufacturing facility, we might not have any engine oils. So let's strip those away too. It is unusual, right, to have a polyalkylene glycol turbine or compressor oil unless you are in the natural gas industry. So I'm going to strip those away. And let's say, for example, a PAO hydraulic oil, they're increasingly rare because there are so many very good Group 3 options available as well. So you don't tend to see too many full synthetic hydraulic oils. Okay, so now what we're left with is a limited range. Now, unless you have, again, you're in the power generation industry, you might not have any turbines on site. So let's pull back on those a little bit. And let's say, for example, that for a generalized industrial site, these might be the types of lubricants that you have on site. Okay. So because there are only, 1, 2, 3, 4, 5, 6 different types of lubricants, now we can play around with the colors a little bit more. But we don't want to just color things by application. Because, for example, let's say, for example, I had a PAG gear oil which is used in a worm drive. I don't want to use the same color as an EP mineral gear oil and a PAO gear oil, right? Because a PAG is very incompatible with those lubricants. We want to make sure that those colors are as far away from each other as possible. And so what we can use is the color wheel, because opposite sides of the color wheel are what we call what is the opposite of complementary? They're opposite of each other. And so the blue and an orange have the most contrast, and therefore you're less likely to mistake them, right? So we want to try and use the color wheel to develop our color coding system. All right. So one thing that we could do is we could list all of the different types of lubricants with their base oil as well as their application. So if I were to do this, right, this is how you could re-articulate these different lubricants, right? So again, we're starting with the type and we're going in order from RNO to anti-wear to EP, right? So increasing in the amount of additives. For the base oil, we're going to start with the PAO, right? So for example, now what we can see is that each line item is kind of next to each other, for want of a better word. So the top two are both RNO PAO oils, but they're used in different applications. So if we mixed up, for example, a PAO compressor oil and a PAO circulating oil, then that will probably do the least damage. Similarly, if I mixed a PAO circulating oil with a mineral circulating oil, again, the damage is not going to be that severe. Now, if I go down the list, I've got a whole bunch of mineral oils that are used in a circulating, a hydraulic, and a gear application. Again, if I mix them, it's not going to give me the optimal performance in a gearbox, but at least it's not going to lead to a catastrophic failure. And similarly with the gear oils, if I mix mineral and PAO gear oils, the performance is not going to be as good, but on the other hand, I'm not going to end up with a catastrophic failure. So now that I've got 6 groupings, I can use my 6 colors to distinguish all of these. The one outlier is the PAG gear oil, and I'm probably going to give that a completely separate color. Maybe it's a black or a brown or a distinct white or something like that, to make sure that people are aware, like alarm, 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 do not mix this with any of the other lubricants on site because it is so different to everything else, right? So that is just an example of how we can break down all the different types of lubricants that we have on site to develop our own custom color coding system. This is obviously very dependent on the types of lubricants that you have. So for example, if you're in the food industry, maybe all of these are food industry lubricants and you use a special color coding system, and you have one lubricant on site which is not food safe, and you want to give it a distinct color so that it's not mixed with anything else. And everyone on site understands, hey, that the ones with the black label with the yellow circle around it, do not use that in anything else, right? Because we could run into regulatory hurdles or compliance issues.